Two identical metal blocks resting on frictionless horizontal surface. Two identical metal blocks resting on horizontal surface are connected by light metallic spring having spring constant 100. Having spring constant 100. And unstretched length, that is original length is zero point 0.3 meter. Total charge Q.
Sir,
Yes, yes, yes.
so there is too much static in the voice.
Now,
Yes, sir, it's all.
okay. So if Q is the total charge given to this block, charge will get equally divided because that spring is connecting spring. Due to this, there is repulsion force, and this gets elongated up to 0.4 meter. Then what is value of Q at equilibrium? This is electrical force acting outward. Spring will try to bring it back. That is called restoring force. So I can say at equilibrium, electrical force or electrostatic force equals to restoring force. So 1 upon 4 pi epsilon naught q by 2 upon length L2 square when it is stretched equals to restoring force, which is K into elongation. So 9 into 10 raised to 9 into q square by 4 into zero point 0.4 square is K is 100, zero point 0.4 minus 0.3. So we get q square equals to 4 into 16 into 10 raised to minus 2 into 100 into zero point 0.1 upon 9 into 10 raised to 9. So q square equals to 64 upon 9 into 10 raised to 2 and minus 2 get cancelled. 10 raised to minus 10. So Q equals to 8 by 3 into 10 raised to minus 5 coulomb. That will become 80 upon 3 into 10 raised to minus 6 coulomb. So 26.666 in micro coulomb. 26.666. Check option is there. 26. They've rounded as 26.7. So this is 26.7 micro coulomb. Who had not written the test last time? Vedika, you wrote the test?
Yes, sir.
Sir,
Yes, okay.
I did not give that.
Pratik, na?
Sir, Medhaj.
Miraj, three of you have not given. Paper I have corrected, I will send it today. Yes, you gave? Yes, Shawan? And Viraj, you wait after the class?
Done, sir.
49. Electric field inside spherical shell of uniform surface charge density is. What is electric field inside the charge sphere? Zero.
Yes, sir.
So electric field inside charge sphere is zero. Option A. 58. 3 point charges Q plus Q minus 2Q and plus Q. Plus Q minus 2Q and Q are situated at 0 A 0 0 0 0 A 0 0 magnitude and direction of electric dipole moment vector of these charges. So dipole moment is due to equal and opposite charges. So plus Q opposite will be minus Q, and this plus Q's opposite will be again minus Q. So minus 2Q I can split as minus Q minus Q. Now this becomes one dipole and this becomes another dipole. Direction of dipole moment is outward, P1. This is P2. Now P1 value, P2 value same. So, and they are perpendicular. So P1 is same as P2 and perpendicular. That means P net is root 2 times P1, which is root 2 times P is charge into distance between them is A. And direction is on the bisector of PP. So it will be passing through A, A and 0. Passing through A 0. Yes, you wrote the test, Friday's test?
Yes, sir.
Okay. Pratik, you have done the test? Completed 58th?
Yes, sir.
51. Angle between electric dipole moment and electric field strength due to pole on equatorial line. Dipole moment is from negative charge to positive charge. This is dipole moment P. And E on equator is parallel to dipole moment in opposite direction. What is angle between them? This P bar and E equator wala angle?
180 degrees.
180 degree. 52. At a given charge is situated at certain distance from electric dipole. A given charge is situated at certain distance from electric dipole. There is one charge. In end-on position. End-on position means axis. Broad end means equator. So sometimes this two statement also they can use. Even in magnetism we'll study the same. Then experiences force F, this charge Q. If the distance of charge is doubled, then what will be the force acting? Since force is Q into E due to dipole on the axis, and this is 1 upon 4 pi epsilon naught 2p upon r cube. So we can say therefore force and distance relation is inversely proportional to r cube. Force is inversely proportional to r cube. So first force upon second force is r2 upon r1 cube. Distance is doubled, they are saying. So therefore F1 upon F2 is 8 by 1. So F2 will become 1/8 of the original force. 1/8 option is given in D. Yes, everybody has followed?
Yes, sir.
Okay.
Yes, sir.
Okay, right. Today first lecture, which lecture was there? First one?
Chemistry.
Chemistry.
Lecture.
Hello? हाँ तो लेके आ जाओ. Completed?
Yes, sir.
Yes, sir.
53rd. An electric dipole is placed along x-axis at origin O. Origin O. A point P is at distance of 20 from O, such that OP makes angle pi by 3 with x-axis. If the electric field at P makes angle theta with x-axis, electric field makes angle theta with x-axis. So if I extend this and draw parallel to this, then this is electric field making angle total theta with x-axis. Then what is value of theta? See, this angle, this much, is called as alpha. Tan alpha is half of, इसको phi बोल देता हूँ, tan phi. ये relation है between angle for electric field at any point and the angle phi. Tan phi is half tan theta. Tan alpha equals to half tan phi. So tan alpha equals to half of tan pi by 3. Therefore, alpha will become tan inverse of half tan pi by 3. That means tan inverse of tan pi by 3 means tan 60. What is tan 60? Is it root 3?
Yes, sir.
Yes, sir.
Tan 60 is root 3. Tan 60 is root 3. Therefore, total angle theta equals to alpha plus 5. Alpha is tan inverse half, that is root 3 by 2, and phi is, because these two angles will be corresponding angle, plus pi by 3. Just check where is this option? B. Yes, followed? Hello, have you followed this?
Yes, sir. Done, sir.
P4. P4th one. An electric dipole consists of two opposite charges, each of magnitude 1 microcoulomb, separated by distance of 2 centimeter, that is 2 into 10 raised to minus 2 meter. Dipole is placed in the field of 10 raised to 5 coulomb. It should be Newton per coulomb. The maximum torque. What is formula for torque acting on dipole? PE sine theta. Torque. And maximum torque is PE. P is Q into length. Length is 2 into 10 raised to minus 2. And Q is 1 microcoulomb, that is 10 raised to minus 6. E is 10 raised to 5. So it is 2 into 10 raised to minus 8 and 3. Minus 3 Newton meter. Option C. Direct formula based.
Done, sir.
55. An electric dipole has the magnitude of its charge as Q. Dipole moment is P. Electric field E. Dipole moment is along the direction of field. Along the direction of field means theta is 0. Then find what is the force acting on it and potential energy. Force acting will be 0 because if this is dipole and this is field, here the force will be QE and here also force will be QE, equal opposite. So force becomes 0. Potential energy R. Force is 0 and potential energy will be minimum because it is stable condition. Potential energy is minimum. So force 0, potential energy minimum when it is in equilibrium position. Option C. In the direction of field or opposite, always force is 0 and energy is minimum. Fifty-sixth. Positive charge Q and negative charge minus Q are placed at x equals to a minus a and x equals to a. The variation of potential we have to find from the given graph. Plus q charge is on left side, minus q charge is on the right side. When x is minus a, charge is q at distance minus a. See, for negative charge, potential is negative, or for positive charge, it is negative. Hello? For negative charge, potential is negative, or for positive charge, it is negative. Tell fast. Potential is positive for positive charge or negative for positive charge, or it can be any.
Positive for positive.
For positive, potential has to be positive. मतलब ये positive के लिए इधर रहेगा positive. And for negative, it will be negative. This much is correct.
Yes, sir.
और इधर क्या
Yes,
होगा?
sir.
Net potential zero होना चाहिए ना? Because इसका distance q का इधर plus इसका minus distance same, तो potential same, net zero. That means our potential will vary like this. So option will be A. A is the correct option. Pratik, you also wait after the lecture. Now in the class you are writing the test and sending me and giving me message. Please confirm. Done. 55,
Yes, sir.
56, 57. An electron of mass me initially at rest moves through a certain distance in the uniform electric field in time t1. A proton is having mass mp also initially at rest takes time t2 to move through an equal distance in the same field, neglecting the effect of gravity. What is time t2 to t1? So distance covered by kinematical equation is ut plus half at square. Initially at rest, so it will be 0 plus t1 0 t1 plus half a into t1 square. That means s is half of a t1 square. Acceleration means force upon mass into t1 square. So it will be force acting on electron is ee upon m into t1 square, mass of electron, equation 1. Same way for proton, distance covered will be half charge of proton, same electric field, upon mass of proton into t2 square. This is mass of electron me. Equation 2. Therefore, half charge of proton into E upon mass of proton T2 square will be half into charge of electron into E T1 square upon mass of electron. Half E cancel. Charge of electron, charge of proton, same cancel. So ratio of T2 upon T1. This is T2 upon T1 will be mass of proton upon mass of electron in root. That is option B. Have you followed properly?
Yes, sir.
Okay. Done?
Yes, sir.
Question number 58. Two particles of masses m1 is m and 2m with charge 2q each are placed in uniform electric field and allowed to move for the same time. Ratio of their kinetic energy. What is formula for kinetic energy? Hello? Formula for kinetic energy? Hello? Formula for kinetic energy?
half mv square.
Okay. So mass is given. If I get V in the electric field, I can get kinetic energy. They are telling time is same. So two masses with charge are placed in electric field. Are placed matlab initially they are at rest. So we know that V is equals to U plus AT. Time is same they are telling. So V is equals to, this is 0 plus force upon mass into T. Force is nothing but charge into electric field upon M into T. So I get V1 upon V2 will be charge same, E same, T same. So it will come M2 upon M1, which is 2M upon M, that is 2 by 1. Two by 1. Therefore, kinetic energy is half mv square. So first kinetic upon second kinetic is m1 upon m2 v1 upon v2 square. m1 is m, m2 is 2m, v1 upon v2 we got 2 by 1 the whole square. This will get cancelled. So 4 by 2, 2 is to 1. 2 is to 1, option A. Such sums are important. One sum you can expect kinematical type. Once you complete, please tell me.
Done, sir.
The others have also done.
Yes, sir.
Yes, sir.
59th. Here I am. That final answer, whatever we get, you have to please memorize it. N spherical droplets. N droplets. Charge to same potential. Charges is same potential, same way. Charge to same potential are combined to form big drop. The potential of new big drop is how? Whenever you get problem of drop combined to become bigger drop or drop is splitting into droplet, then always first find relation between their radii. N droplet ka volume is n into 4 upon 3 pi r cube. Volume will remain same. This is 4 by 3 pi capital R cube. Volume will remain same. So n droplet becomes single drop, volume is same. Taking cube root. N raised to 1 by 3 R is capital R. So I got relation between capital R, small r. Now total charge Q will be n times small q because charge is additive. We can add the charge. The potential of a sphere is 1 upon 4 pi epsilon q by r. This is formula. The potential of small droplet upon large droplet is charge of small upon charge of large into distance of large upon distance of small. This ratio any doubt? Hello, in ratio any
No,
doubt?
sir.
No, sir.
So V of small is V, large we have to calculate. Capital Q is n times small q. Capital R is n raised to 1 by 3 small r divided by r. This QQ and RR will get cancelled. So V of small upon V of large equals to I want to find V of large. So V of large upon V of small will be n upon n raised to 1 by 3 inverted divided. This 1 by 3 goes up. What it will become? Minus 1 by 3. Hello?
Yes, sir.
What is 1 minus 1 by 3? 2 by 3.
2 by 3.
So V of large is n raised to 2 by 3. V of small. This formula if you can memorize, So if they give in terms of number like 8 droplets, 10, 16 droplet, then directly n ka value you can put. So our answer is T of large is n raised to 2 by 3 times T of small. That is nothing but option D. So okay.
Yes, sir.
Sum number 60. At distance of 5 and 10 centimeter from the surface at distance of 5 centimeters. So suppose R is radius. This is from the surface 5 and from the surface 10. So from center it will be R plus 5 for one point and R plus 10 for another point from center. Potentials are respectively 600 and 420 respectively. Then potential on the surface of sphere. Potential on the surface we want. The formula for potential near charged sphere is 1 upon 4 pi epsilon charge upon distance. So V1 upon V2 will become R2 by R1, which is R plus 10 upon R plus 5. V1 is 600, V2 is 420, equals to R plus 10 upon R plus 5. 6 into 10, 6 into 7 is 42. So 10R plus 50 equals to 7R plus 70. That will become 3R equals to 70 minus 50, 20. R equals to 20 by. Now potential at the surface upon first potential will be R1 upon only R. So potential at surface we want V1 is 600. R1 means R plus 5 upon R. So V at surface will be 600 into 20 by 3 plus 5 upon 20 by 3. So that will become 600. 5 into 3, 15. 15 into 20 is 35 upon 3 divided by 20 upon 3. 3 will get cancelled. So finally it will become 600 into 35 divided by 20. So 20 into 30. 3 5s are 15, 3 9 1 10. 1050 volt is the potential on the surface. Yes, followed?
Yes, sir.
Try it properly.
Done, sir.
Okay. Next one. And electric charge ten raised to minus 3 microcoulomb is placed at the origin of XY coordinate system. 2 points A and B are at root 2. A is at root 2 position. And B is at 2, 0 position. 2, 0 respectively. The potential difference between point A and B. To get potential difference, we require distance. This distance is 2. What will be OA distance? Can you tell? What will be OA distance? Pardon? OA distance. This is root 2. OA distance then?
2.
2 by Pythagoras theorem. Root 2 square 2. Root 2 square 2. Add, it becomes 4. Take square root 2. So distance OA and distance from O to B both are same. Potential will also be same because charge is same. Therefore, difference will become 0. No need to calculate. Understood?
Yes, sir.
Yes, Pratik, Sanskar, Vedant, all the Vedants followed? Vidhi?
Yes, sir.
Okay.
Yes, sir.
Viraj, Neil, Vatsal, Amy, everybody has followed?
Yes,
Yes,
sir.
sir.
Okay. Okay.
Yes.
Solve. See, this chapter is lengthiest chapter. If you have done the theory, paper, everything is corrected, only have to enter the mark and send you. From that only I identified 4 students have not given test. Pratik just now he wrote the test in spite of not listening the lecture and send me, he is telling please verify and confirm. Correct no Pratik? अभी लिखा ना lecture में ही. Yes, completed. 61.
Yes, sir.
Okay. T2. In electric field of point charge Q, a certain charge is carried from A to B, C, D, E. B, C, D, E. Certain charge is carried in the electric field of this. What is this surface called as? ये पूरे surface को क्या बोलते हैं? Equipotential.
Equipotential.
Correct. Equipotential means its potential is same everywhere on this boundary. Same everywhere. So we want to find what is work done in moving the charge from A to B, A to C, A to D, and so on. So if all the voltages are same, VA, VB, VC, VD, VE, all are same. Work done between 2 points is potential between 2 points upon work done to move the charge is potential difference between 2 points. Hello?
Yes, sir.
Yes, sir.
Potential difference will become 0 or not?
Yes, sir.
So work done will become what? 0 only. So it will be 0 along all the path. That means option C. 0 along all the path AB, AC, AD, AE.
Done, sir.
63. If an electron is brought towards another electron is brought towards another electron, means negative charge is brought towards negative, then electric potential energy of system will be electron will repel or attract?
Repel.
Repel.
Repel. That means electron brought towards another electron means work is done against repulsive force. Therefore, potential will increase. Potential will increase. Option A. If it is along the field, decreases. Opposite, increases. No field, constant. No field, potential is not zero. Potential is constant.
Done, sir.
Three charges Q plus Q plus Q are placed at the vertices of right angled isosceles triangle as shown. In the figure, net electrostatic energy will be plus Q, Q, Q is placed in right angle isosceles triangle as shown in the figure. So if this is A, this is A, this will become root 2A. The net electrostatic energy is 0, then what is capital Q? So net electrostatic energy is 1 upon 4 pi epsilon naught Q1, Q2. If I call this as 1, this as 2, this as 3. So Q1, Q2 upon distance between 1, 2. Q1, Q3 upon distance between 1, 3. Q2, Q3 upon distance between 2, 3. This is to be 0. So 1 upon 4 pi epsilon naught Q1, Q2 will become QQ upon A. Q1, Q3 will become capital Q, small q capital Q upon A. Q2, Q3 will become small q capital Q upon root 2A. So this will become 0 equals to 1 upon 4 pi epsilon naught A inside Q square plus QQ plus QQ upon root 2. This whole thing puts on that side becomes 0. So 0 equal to Q square plus QQ common inside 1 plus 1 upon root 2. So therefore Q square minus is QQ upon 1 plus 1 upon root 2. 1 Q gets cancelled. Therefore capital Q is minus Q upon 1 plus 1 by root 2. Now checking the option. This if you simplify it will become minus Q root 2 plus 1 upon root 2 will go up. Plus root 2. See, numerator is given 2. So if I multiply numerator and denominator by root 2, we will get correct option B. Okay? If you multiply numerator by root 2 and denominator also root 2, then it will come same as B. Hello?
Yes, sir.
Okay. Followed now meaning if I rationalize multiplying numerator denominator by root 2, so Q root 2 is 2, denominator root 2 into root 2, 2, second term will be root 2. Anybody who has not followed what I told last line? Yes, you all have followed na last line?
Yes, sir.
Understood, sir.
Okay.
Yes, sir.
Right.
Done, sir.
Work done in carrying charge of 5 microcoulomb from point A to point B in electric field. Work done to move from A to B is 10 millijoule. That means 10 into 10 raised to minus 3 joule. Charge of 5 microcoulomb 10 raised to minus 6 coulomb. Then what is potential? PV minus VA is work done to move from A to B upon charge Q. Work done is 10 raised to minus 2 and charge is 5 into 10 raised to minus 6. That will become 1 upon 5 into 10 raised to plus 4. 10 upon 5 into 10 raised to 3 volt, which is 2 kilovolts. A option, 2 kilovolts.
Done, sir.
66th. A body of mass 1 gram carrying charge of 10 raised to minus 8 coulomb passes through 2 points P and Q. P and Q are at potential of 600 volt and 0 volt. If the velocity of body at Q is 20 centimeter per second, then its potential at P will be how much? Potential at P will be how much? Mass is 1 gram. Hello? Hello?
Yes, sir.
Yes, sir.
What are formula for potential energy? Kinetic energy?
Half
mv
mv
square
square.
is
This
one
way.
formula. This is one formula. Then kinetic energy is QV is also formula, where V is potential difference. If potential is increasing, one minute. Yes, ma'am. No problem, madam. What time is convenient for you? 12 o'clock if I call, will it be okay? No problem. Yeah, I have got lecture. So if it is possible for you to call at 12, will it be okay? Okay, ma'am. Okay. Yeah, thank you. Thank you. See. this is voltage here 600, here voltage 0. That means kinetic energy is not accelerating but deaccelerating. Huh? Correct?
Yes, sir.
So half m velocity at q minus half m velocity at p is equal to charge into potential difference. I wrote like this because there is a decrease in potential. Have you followed this first line first? Change in kinetic energy is q into v. Say kinetic
Yes,
energy
sir.
formula half mv square and potential difference is q into v. So change in kinetic energy is due to deceleration. So this line if you follow then it is very simple. Everybody has followed till this?
Yes, sir.
Okay, so half m vq square minus vp square is q into v. So half vq square minus vp square is 2qv upon m. 2qv upon m. So vq square minus vp square is 2. Charge is given 10 raised to minus 8 coulomb. Potential difference is 600. Mass is 1 gram, that means 10 raised to minus 3 kg. 6 into 2, 12. 100 into 10 raised to minus 3 goes up plus 3. Minus 5. So this is 12 into 10 raised to minus 3. Please copy till this. So VQ square will be VP square plus 12 into 10 raised to minus 3. VP square. V square is actually VQ square minus 12 into 10 raised to minus 3. This is 20 centimeter. So converting into meter, 2 into 10 raised to minus 1, the whole square, minus 12 into 10 raised to minus 3. 4 into 10 raised to minus 2, minus 12 into 10 raised to minus 3. So 40 into 10 raised to minus 3, minus 12 into 10 raised to minus 3. 28 into 10 raised to minus 3. So Vp is root of 28 into 10 raised to minus 3 in meter. That is nothing but option A.
Done, sir.
Electric potential at a point P x y z is Vp is minus x square y minus xz cube plus 4. Electric field E is given by. To get electric field, we have to find x component by partially differentiating this with respect to x minus of this, then y, then z. And once we get all, E bar will be Ex I cap plus Ey j cap plus Ez k cap. So differentiating this, we get minus of, with respect to x means only x is variable, rest all are constant. So in x square y is constant, x square minus x square will become minus 2x. Then minus z cube, x is 1 and this is 0. So we get plus 2xy plus z cube. Similarly, y is derivative of v with respect to y in minus. So minus x square, y ka derivative 1, rest all will become 0, 0, 0. That means you will get plus x square. Then z, derivative of v with respect to z in minus, so minus of. X square y is constant, so 0. X is constant, z cube will become 3z square. So it will become minus minus plus 3xz square. So our E bar will become 2xy plus z cube I cap plus x square j cap plus 3xz square k cap. 2xy minus 2xy plus x square, yes. Option B. D option. Completed? 67?
Yes, sir.
That's what points A, B, C. A, B, C. In the electric field. And what is relation between potential? See, potential and E are always perpendicular. So this will be equipotential line. So VA is same as VB, equipotential line, because E is perpendicular to equipotential line. And when you go in the direction of field, potential decreases. So VC is less than VA and VA is equals to VB. VA equal to VB and greater than VC. Therefore, option B. VA is equals to VB, both are greater than VC. Option B. Same line, potential is same because it is equipotential surface. As you move in the direction of field, potential will decrease, so VC will decrease. Done? 68?
Yes, sir.
Equipotential surfaces are shown. This is 10, 20, 30. I think similar type we did earlier also. This is 10, 20, 30 in centimeter. Electric field strength and direction also they want. First direction part is very simple. Electric field is perpendicular to equipotential surface. तो पहला मैं perpendicular बना देता हूँ. Perpendicular. Now perpendicular upward or downward we have to check. So potential is increasing here. This way to the right. That means it is moving against the field. So field ऐसा चाहिए. Potential increases opposite to field. Therefore, if it is going on the right, this should be on the left. Now, what is angle made with x-axis? ये 90 है. Is it 120 degree?
Yes, sir.
So angle I got 120. Now magnitude. E is dv upon dx. Dx means perpendicular distance. So this angle is 30. This will be 30. This distance is 10 and 20 ka difference. That means 10. So this will become 10 sine 30. Side opposite to 30. Side opposite is in sine component. So 10 sine 30. ये समझा distance वाला part. 30 का सामने तो हाइपोटेन्यूज का साइन बाजू में रहता तो कोसाइन. क्लियर?
Yes, sir.
So dv is 20 minus 10 and dx we got 10 into sine 30 because it is in centimeter. Convert into meter by multiplying with 10 raised to minus 2. So 10 upon 10 into half into 10 raised to minus 2. 10 cancel, 2 will go up. So 200 volt per meter, making 120 degree with x-axis. That is option C. Yes, direction part everybody has followed.
Yes, sir.
Always field is perpendicular to equipotential surface, and because potential is increasing on right, ये arrow left में होना चाहिए. Then angle with x-axis is 120 as per geometry. E is potential difference upon distance between 2 points. Perpendicular distance is 10 sine 30 in centimeter. I converted into meter. So we got correct answer as C. Copy 69 properly. Completed?
Yes.
70th. And infinite conducting plate. Infinite conducting plate. If it is conducting plate, means there is no field inside. Only the field will be outside. This is 0 0.03, 0 0.02, 0 0.02 meter. Potential here is 0. So this is low potential, this is high. Always field moves from positive to negative. This one is V3. We have to find what is V3. Suppose this is V1 and this is V2, we have to find V3. E is given 400 volt per meter. So between these 2 points, E between these two will be V1 minus V0 upon distance 0.0. Because left hand side is higher potential, therefore I took higher minus lower. So 400 is V1 minus 0 upon 0.02. Therefore V1 equals to 400, 0.02 will become 8 volt. 4 to the 8. Now V1 will be same as V2 because field is not present, potential is constant. Then again E will be V3 minus V2 upon distance between them. So 400 equal to V3 minus 8 upon distance 0.03. So 12 equals to V3 minus 8. 20 equals to V3. V3 is 20. Okay. 70th over.
Yes, sir.
71. A point charge Q is placed at one corner of this cube. placed at one corner of cube. A, B, C. What will be the flux through phase ABCD? Flux through this one phase ABC. See, first we can find flux by using Gauss's theorem if charge is enclosed. So imagine some Gaussian surfaces, symmetrical one. So iska बाजू में if I assume one more cube, will the charge get enclosed? Will the charge get enclosed? वो इधर है. Will it? So एक ऊपर एक इधर. If I consider this two, अभी पीछे साइड पे एक कंसीडर कर दिया क्यूब. 1, 2, 3, 4. So total 1, बाजू में एक 1, 2, पीछे 2, 4, ऊपर 4. So will it be enclosed inside?
Yes, sir.
Yes, sir.
So I require total 8 cube to enclose it. So we can say if 4 cube 1, 2, 3, 4, 4 cube below and 4 cube above is placed, then Q is enclosed. So now it will become flux through 8 cubes equals to Q upon epsilon naught. Q inside upon epsilon naught by Gauss's theorem. So flux through 1 cube is 1/8 up into Q upon epsilon. The 1 cube has got from here 3 faces which are touching this one, upper one, lower one, and this front. So it becomes flux through 3 faces equals to 1/8 Q by epsilon naught. One face this, ये वाला तीन टच है इसको, टॉप, लेफ्ट, बिहाइंड, तो 3 फेस से फ्लक्स थ्रू one face will be 1/3 of 1/8 upon Q by epsilon naught. So 1/24 Q upon epsilon naught. See again. This is Q. चार्ज इधर है, तो इसको एनक्लोज करने के लिए लेफ्ट एंड बैक साइड 2, 3, ऊपर 4, तो 8 क्यूब से के बीच में आ गया. तो फ्लक्स थ्रू 8 क्यूब मिला, फ्लक्स थ्रू 1 क्यूब मिला. आई वांट वन फेस, तो ये क्यूब इधर है, तो इसको टच करने वाला एक फेस ऐसा, दूसरा फेस ये, थर्ड फेस विच इज बिहाइंड. तो 3 फेस से वो पूरा फ्लक्स इज पासिंग ड्यू टू दिस चार्ज. रेस्ट ऑल आर मूविंग आउट. और ऐसे वाला 3 फेस. So one phase is 1/3 of 1/8, 1/24. 1/24 option, just check. Yes, D. Have you followed meaning first?
Sir,
Yes?
but the Q is not touching ABCD.
No, this phase means this phase, one and the same. Na? Both are parallel.
Okay, sir.
Okay, finished writing?
Yes, sir.
You all write homework